Right, hello, welcome to equations. Alright, so there's basically many ways to look at solving equations, but I really want to work on your setting out of equations because it'll help you when we get more difficult ones even. So when I look at this first question here, there's basically, I've got something plus 3 is equal to 5, and you know, you could probably do that in your head because it's pretty easy numbers. So and you know that the answer 2 plus 3 equals 5, so m was equal to 2. But one way that I could do that is to think about trying to solve equations by thinking about, well, in the end I want it to say m equals, and so I look what happens to m, and m's been plus by 3, so I want to get rid of that plus 3. So I can think of it as going, well, m plus 3, I want to get rid of that 3, I have to minus it. Okay, see, plus 3 and minus 3 equals 0, so I'd be just left with the m on this side of the equation. On the other side of the equation, I want to keep it equals. Now I've minus 3 to this side of the equation, so to keep it equal, whatever that 5 was, I have to minus 3 from that. And so I end up getting 5 minus 3 is 2. And that's your answer. In the same way, I've got 5w, and in the end, I want this thing to be equal to w. And so how do I get rid of this 5? Well, the w has been times by 5, and what I could do, this w here is just really the same as 1w. So what I could do is to get rid of it, I do the opposite of timesing, which is divide. So I've got 5w, and I divide it by 5, which means that they cancel out, and I just get left with that w. And because I've done it to that side of the equation, I had to do it to this side. I had 20, and I divide it by 5, and I've got, how many times does 5 fit into 20? It's 4. Now you can see I'm moving through. Now I've got in the end I want this to be equal to k. I've got k minus 8. To get rid of that minus 8, do the opposite of minusing, which is plussing, plus 8. Because I plus 8 to that side, I should plus 8 to this side. And so these things will cancel each other out to just leave them with a k. And minus 2 plus 8 is 6. We can check that. 6 minus 8 is minus 2. Last one. I've got q divided by 5 is 3.2. So the opposite, I want that in the end to say what q is. So I've got q divided by 5, and if I multiply it by 5, it's going to then, that will cancel with that, and I'm left with just q. So, and if I times this side by 5, I have to do the same to the other, 3.2 times 5, and 3.2 times 5, well, 3 5s are 15, and should be equal to 16. Let me have a look. 3.2 times 5, 16. Gives me 16. So they're my basic skills. I'm basically trying to undo what's been done to the letter. So this is the long way how to do it. We'll look at it again. If I've got m plus 3, it's been plus by 3, so I'm undoing what's been done to that which is minusing. So that's what I've done. I've minus 3 here. I do it to both sides actually. Here it's been times by 5. I undo that by doing the opposite of timesing, by dividing. Here I've been minus by 8. I undo that minusing 8 by doing the opposite, which is plussing. And here it's been divided by 5. I undo that dividing by 5 by timesing. The opposites are key. So these are two-step equations, and so in the same way, I'm trying to find out, actually, I'm trying to see what x is going to be in the end. And so what's happened to x? It's been times by 3 and then minus by 2. So I need to undo that. The first thing I'm going to do is get rid of that minus 2. And I might do this the long way to start with. So 3x minus 2, to get rid of that minus 2, I'm going to plus 2. so I have to plus it to this side too. So then I get, well, those two things will cancel out. Minus 2 plus 2 gives me 0, so I'm just going to be left with 3x is equal to 12. And then I've got timesing by 3, so I'm going to go 3x divided by 3 and 12 divided by 3. They'll cancel out, and 12 divided by 3, x is going to be equal to 4. Okay, but really I've added these extra steps in here, which I would recommend doing to start with, but later on you can get rid of. So, but some things I want you to keep in mind too is that I've got all these equals under each other, except for the one over there. I would have put that under there too if I didn't already write that other one there. So here's my strategy. I'm keeping an equals underneath each of that one. In the end, what I want it to look like, I want it to be x equals. So what's happened to x? Well, it was divided by 4, then minus by 1. I want to get rid of that minus 1 to start with. How do I get rid of it? I do the opposite. X divided by 4 minus 1. If I plus 1, it's going to get rid of it. And I have to do the same here, plus 1. It's going to give me 6. And this is going to just give me like that because they'll end up getting 0. Now, x on 4, I have to times it by 4. 6 times 4. They'll cancel each other out there, just leave me with the x, and 6 times 4 is 24. This one, I've got x plus 2, it was plus by 2 and divided by 3, so the first thing we're going to do is times by 3 to get rid of that. X plus 3, plus 2 on 3 times 3, minus 4 times 3. Minus 4 times 3 is minus 12. They'll cancel out. I'm just going to be left with x plus 2. X plus 2 minus 2 minus 12 minus 2 with x minus 14. So these ones I've got these extra steps in. What you could do is you could solve them like this. 3x minus 2 equals 10. Keep your equals underneath each other. The first thing I need to do is get rid of that minus 2. So plus 2 gives me 12, leaves me with 3x. Then to get rid of the timesing by 3, I divide by 3, so x is going to be 12 divided by 3. X equals 4. You could do it like that. Okay, I need to minus opposite of minus 1, plus 1, 6. Opposite divide by 4, times by 4. This one, x plus 2 on 3 equals minus 4. I times by 3, oops, is minus 12, and minus 2 okay. These ones are extension ones for year 9, but I think it's worth having a look at. We sometimes think about balancing equations. I've got 6x's minus 2 and 4x's minus 4. And in the end, what I want it to say x equals. But the problem is, I've got, like balancing on the fulcrum like a seesaw. Got 4x's on there and 6x's in there. So what I can do is, if I took off 4x's from here, then this thing's going to tip. This is going to tip. It'll go that way, and this will go down. So if I take off 4x's from there, I have to take 4x's from here. So if I got rid of this 4x's here, I'm just going to be left with minus 4. I would also have to get rid of 4x's from here. I'll do the long way. So 6x minus 2 minus 4x. 4x minus 4 minus 4x. So that's going to go with that. And leave it with minus 4. 4x's, 6x's taken by 4x's is going to be 2x's. And we've still got that minus 2. Okay, and now to solve this thing, what do I need to do? I need to get rid of that minus 2 by plussing it. 2x minus 2 plus 2 minus 4 plus 2. They'll cancel out, so I get 2x. Minus 4 plus 2 is going to give me minus 2. And then to get rid of that, I need to divide it by 2. Divided by 2 minus 2 divided by 2. They cancel out. X. Oh, you're dividing by itself, so it gets 1. So x. Oh, sorry, that's not right. That should not have been a negative. Minus 2 divided by 2. How many 2's fit into 2? 1 fits in, but it's a negative, so it's negative 1. That's that, and I've done it a long way there. I've done those extra steps in there to show you. If I show you the long way, it makes a bit more sense. If I was doing it a shorter way, I would do it like this. Keeping my equals underneath each other. I want to balance. I want to get all the x's onto one side, and so I'll get rid of the one that's got the least amount of x's. The 4x's, I'll get rid of the 4x's of those, leaves me with that. If I get rid of it from this side, I have to do the same to the other. 6x take away 4x is 2x minus 2. That was a minus 2, by the way. Now I've got a question that I'm used to seeing. The opposite of minusing 2 was plus 2. So I've got 2x, and minus 4 plus 2 is minus 2. I divide it by 2. Minus 2 on 2.